Hello, here is Peter Larsen from Loudsoft. This time I want to show you some of the key features of fine crossover. This example is a two-way design where I have measured responses for every 15 degrees, and you can see the black curve here is the 30-degree off-axis response, and the system was optimized for that, and it was using the green line here, which is the target. Always you can click on any component and then change the value like I do now. This I do with the mouse wheel, and you can see that all the curves update simultaneously. That includes the phase and the impedance. So now I can try and go somewhere off, and then we will try and optimize the system again. And you can see it does that quickly, and it also considered the low impedance, which is the option here. So you can see it's above the minimum. This is a 4-ohm system. We can also see the power that goes to each driver. In this case 17.5 watts to the woofer when we have a main input of 70 watts, and only 1.48 watt to the tweeter. And this is very important information, because one of the purposes of the crossover is to protect the tweeter and all the drivers for that matter. So now I will show how to do a two-way crossover design. We import measurements. Here's an example. We can just take any responses we can think of. That includes Melissa responses, text files from nearly every system. Once we've done that, we need to set the target level and do the same thing for the tweeter, and now we're ready to begin. Here we have the low pass filter. We can have from first order up to fourth order, and every time you can see that this is actually what's happening. I can move the crossover frequency and the components update at the same time, and you can see that the response is far from the target. So let's see what we can do about this. Now let's just do a simple second order crossover, and I will take this as Lindquist-Riley because that works quite well. So now I have chosen a crossover frequency maybe close to 1500, and you can see it's still not very good, so let's do something about that. Now we can optimize these two components, and you can see now we came to a response which is actually quite close to the target. So let's move on to the tweeter. With the tweeter we can do the same thing. We can change the crossover frequency, so we should try and arrive at the same as before. Let's go for Lindquist-Riley this time and keep the target as the network. This time we also need some attenuation, and I can just put in some attenuation and then let the system optimize. So here we will optimize this circuit now, including the resistors here for the attenuation, like that. And now we have optimized the two sections, and we are ready to move on to the final design. Here we can see the resulting response, which is not that good. It did not add up really well. So we need to optimize this again, and let's just do that. And now I can see that this parallel resistor, maybe I don't really need it, but the system actually tells me, because it has optimized it nicely, and it says this is 1 mega ohm. In other words, we can just leave it out, and then we have simplified it and we have a nice response. Now let's move on to a more advanced three-way design. In this example I have already optimized the sections, and all we need is to optimize the final response, and we do it the same way as before. We simply set it to optimize, and we can see that it does it really well this time also. So let's move on and see how we actually made these sections. So here is the woofer section, and we want a crossover frequency of 500 Hertz. and we can see the response of the woofer is actually this pink curve here, which is a very high peak here at 4K. So we really want to attenuate that. So we have chosen a third order crossover this time, and let's try and see if we can optimize this a little better. Yes, but it's not really flat here, so we want to do that a little better if we can. So let's see if we can try and find a way to overcome this problem. And the problem comes from the rising impedance. It has a very long voice coil, and therefore the impedance is very high. We can do something about that. We can insert a compensation circuit like this capacitor and resistor. So at high frequencies the capacitor will have a low impedance, so that the impedance here is very low, and therefore shorting the rising impedance. Okay, we will choose this, and this time we will try and optimize again. Aha, this way it worked a lot better. We can see there's actually one component which is 0. We will leave it there because we may need it later, but it's interesting that it actually found a good curve without using the third order crossover. Okay, let's move on and look at the mid-range. The mid-range should be ideally a band pass response, and you can see the target there. 500 Hertz there for the low end is good, but maybe we should do the high end a little better, so we could try and go for something like 4 kilohertz. Yeah, let's try that. Here we go. And again, we need attenuation, which we have just set, and then we will try and see if we can get this done by the system. And certainly we could. So now we have optimized the mid-range, and we can move on to the tweeter. So this is the tweeter section, and we have 4 kilohertz crossover as before, and we can see we can just optimize this with attenuation. But we notice that the slope here is different to the target. So let's try something special. If we uncheck this one and go on, now we can have a different choice of targets. So we can actually even have a fourth order target if we wanted to, but we can change it. So let's try this slope, which seems to match the real tweeter response. And now we'll just optimize with this one, and we got a very good response from the tweeter. So now we are done with all the sections. So let's take a look at the final optimized three-way system. We can see that down here it's actually only second order, because the third order component was removed because we had the compensation circuit, and that was enough to build a very good response. So it actually saved a component by itself, and this we frequently find that the program will tell us how many components we need. We also see that this inductor here has now a series resistor, which real inductors do have, so we can just put it in there, and then when we do the system we can just optimize it again if we didn't have it in the first place. We also notice that the mid-range is actually out of phase. It's inverted, and that's a very normal thing to do, and you can see that it works quite well because the phase response here is actually close to ideal. These lines should be ideally parallel. This is not bad. So this is considered a quite good design. However, there are other ways to do it, and I will show that just in a little while. Now we had the mid-range out of phase, as you can see here. We can actually try to undo that. Let's put it in phase. Oh, we can see now the response has a big problem. But we have another way we can do this. We can place the drivers differently in time. So we can change the position and therefore the timing of the different drivers. This is a little more delicate work, and you can still optimize sections and so I'll just show the finished result. So here's the final optimized three-way design with the mid-range in phase. And you can see now we have actually modified the position of the drivers with delays so that it actually adds up quite nicely. You can see that the crossover frequency has been lowered regarding to what it was before. It's much lower now, but still the system works quite nicely. The phase response looks good. So this is just another way to do the design, and you have the freedom to do that. The system will help you to do it. Finally, I will show you some other options. So here's the Loudsoft webpage, and here you can get more information about all the software. For instance, you can go to the Crossover webpage and read a lot more, and you can also go to downloads and get the fine crossover tutorial, like here. There's also some articles here. One is crossover designed by software, which is recommended. Thank you.